Hello team, this is Monene Engineer. Today I'm going to begin on a series of videos where I will discuss about the structural concrete project. First I may ask, where do you start? When you're constructing a structure, when you're designing, especially designing, where do you start? And I found the best solution is that when you're constructing, you start from the foundation, but when you're designing, you have to start from the top. Why do you have to start from the top? The top part of the building has no road to bear, so you need to start from there so that you can go down while analyzing every load that is on top of each other. There are two types of building. That is a mansionette or a bungalow. A mansionette is a house where it has a slab on top. That is its form of roofing is a slab roofing. Then we have a bungalow where you have to design for the trusses to hold the iron sheets. And when you are doing all this, you have to design from the top. You have to design for a bungalow, you have to design the trusses first so that they can hold the iron sheets. They have to be strong enough. You have to from there you have to check the live load that will be bared by that truss, that is the iron sheets, that is dead load. Then the live load, that is maybe the solar system or any other thing that you want to put on the roof. From there you design the beams that will carry these trusses. If you are planning to design for the beams to carry your trusses, or maybe you can design for the columns to carry your trusses. Then from there you go to the foundation, where now you design a foundation that will carry this load, distributing it to the ground safely. Then you need to check, of course, the geotechnical part of the soil to see whether it can really bear this load while choosing the best type of foundation that you recommend. There are many types of foundations. You can have the shallow foundation, where you have the pad foundation, the strip. We also have the raft foundation. Then for the deep foundation, that is where the soil is too weak to hold the building, you can use the piles foundation. Then we have the drilled shaft. All this is to try and bear this load. Now for my case, in this series of videos, I will discuss more about the design of slabs. That's the first thing you need to design. Then you design for the beam that will bear this this slab. Then from there you design the column that will bear this slab too. So in all this, you have to check the load analysis. You have to check all the dimensions you need, and you will be good to go. So for the slab, we will be discussing more about the types of slab. You can have a simply supported slab, you can have a cantilever slab, you can also have a continuous slab. It depends on the position of the structure, how you have designed it, how you want it to look like. Then we will go to the span and all that. We'll check a lot of things. We'll check the cover, the fire resistance. We will check the loading, the span depth ratio, a lot of things: the load, the moment, the reinforcements, how to check the best suitable reinforcement. Then we'll check the deflection. From there you will check the shear. Shear check will enable us to get those joints, whether they are really strong enough to hold the building. Then we'll check the clacking, and we will be through. Then from there we will design for the beam. The beam, we will also check whether it's simply supported, continuous, or cantilever. We will also check it, almost the same process, but there is some differences somewhere that we will discuss. We will also check whether the beam is flanged or just rectangular. We will also check whether we are dealing with the L beam. L beam is on the edge of a building, then the T beam is in the middle, and all that. Then from there we will check the column. We will design for the column, the best suitable column. This column, and I want to leave this question: why do you need to design a column of the same strength up to the top? Is it really necessary? Is it a good idea or not? Bearing in mind that you can build a house of 50 stories, and you know very well that the beam at the ground level, the first floor, the second floor, will need to be strong enough to bear the load from the top. Do you really need to design a column of the same strength at the 5th floor? Leave that question on the comment section. You'll discuss it, and I think you can give some comments. Then the next video you will see about it. Okay, thank you so much, and please subscribe to my channel, and goodbye.